Hello students. In this lesson we're going to determine a volume of a solid of revolution that will be revolved around a horizontal line. In this case it'll be y equals 2.5. This is a nice example because it's revolving the solid around the line other than one of the coordinate axes. Okay, and we'll have a region determined by the intersection of e to the minus x, 1 minus e to the x, and the vertical line x equals 0. So let's graph these curves. So we have y equals e to the minus x. Okay, that's exponential decay, and this is the y equals 1. And then we need to graph 1 minus e to the minus x. So if you notice, if you're wondering how to graph things like that, just sketch them by hand. E to the minus x is exponential decay. Minus e to the minus x is a reflection of that around the horizontal axes, and then you're adding 1, and so you're giving that a little bit of a boost, and it'll go through 0 there, and then they'll intersect here. Okay, so this is the graph of 1 minus e to the minus x. Okay, next let's find this point of intersection. Okay, so this is x equals 0, and then we need to find this point of intersection here. So we're going to revolve this little shape around 2.5, but we need to find out what this point is, and it turns out that it's natural log of 2, and that's real simple. You just have to find out where these curves intersect, so you just set them equal to each other. You add e to the minus x over to the other side, you get 2 of them, then you divide by 2, then you take a natural log to get the exponent, and then you get minus natural log of 1/2 is equal to x, and that means x is equal to the natural log of 2. There's a couple ways to manipulate that to realize that that's the natural log of 2. For example, you could use the property that minus the number in front becomes the exponent, and so then you flip it. The other thing you could have done is the natural log of 1 minus the natural log of 2. Natural log of 1 is 0, and then minus natural log of 2 would give you natural log of 2. All right, so now we're going to revolve this shape around y equals 2.5. So I'm going to give a sketch of that here. And you see we get this washer as we revolve that around 2.5 here. So then if we look at that face on, here's 2.5 in the middle. And then you get an outer radius, which is determined by 1 minus e to the minus x and 2.5, and then e to the minus x and 2.5, the differences between those curves. So you get an outer radius of 2.5 minus 1 minus e to the minus x. And so if I simplify that, I'll get 1.5 plus e to the minus x, and then the inner radius will be 2.5 minus e to the minus x, and that's 2.5 minus e to the minus x. And then we're going to be integrating from x equals 0 to x equals the natural log of 2. So x is bounded between 0 and natural log of 2. So let's set that integral up. So we have the outer area, which is pi times the outer radius squared, minus pi times the inner radius squared, as we've denoted here and here. And remember, x is bounded between 0 and natural log of 2. So we just have to square these out and then just perform this integration. Okay, I'm going to clean this up a little bit. All right, so the volume is pi, I'm going to factor the pi out, times this outer radius squared minus the inner radius squared. We're integrating from 0 to natural log of 2, so I'll square this. 1.5 squared is 2.25. Then, you double the middle term, so 2 times 1.5 is 3. And then e to the minus x times e to the minus x is e to the minus 2x. And then we'll have a 2.5 squared is 6.25. Then 2.5 gives us a minus 5. And then minus e to the minus x times minus e to the minus x is plus e to the minus 2x. Then I'll distribute this negative sign, there's negative 1 out in front, so that'll give us a minus 6.25, a plus 5 e to the minus x, and a minus e to the minus 2x. And then we'll simplify the integrand. So the e to the minus 2x's will cancel out. We'll collect 2.25 minus 6.25 gives us a minus 4. 3 e to the minus x plus 5 e to the minus x gives us an 8 e to the minus x. And so then we just integrate this thing. We get a minus 8 e to the minus x, and then minus a 4x. We're integrating from 0 to natural log of 2. So I'll plug those in. Minus 8 e to the minus natural log of 2. Now remember, e to the minus natural log of 2, that's going to be that's natural log of 1/2, right? So the 1/2 is going to drop down and give us a -4. -4 natural log of 2 will stay there. -8 e to the 0. E to the 0 is 1, so that gives us a +8. The pi's I factored out and parked it right there. And then 4 times 0 is 0, so that's gone. So 8 minus 4 is 4. And then we have a -4 natural log of 2. So if I factor out the 4, I get 4 pi 1 minus natural log of 2. I know I went through that integration pretty quickly, but I'm assuming that if you're solving problems like solids of revolution, that you can handle the integration at this point. So I'll leave this up for a moment and you can work through that integration. Okay, good luck.